In this video we're going to talk about some of the rules we've already used, as well as introduce the inverse trigonometric derivative rules. This first one, we're going to find the derivative. You notice that it's both a function of x and y, so it's actually not a function, but it's got x and y's, so we're going to have to find the derivative implicitly. So the derivative of x squared is 2x. The derivative of y cubed is 3y squared dy dx. Now xy, we're going to need to use product rule, right? We have a product x multiplied by y. So we're going to do first multiplied by derivative of the second plus the second multiplied by derivative of the first, which is just 1. The derivative of 6 is 0. Right. Now, we move all the things. Well, let me start by just rewriting this now with kind of cleaned up. We've got 2x minus 3y squared dy dx plus x x dy dx plus y equals 0. I'm going to move all the things that don't have a dy dx. So I'm going to subtract y. Do that in a different color. Subtract y. Let's go in here. Subtract 2x. Let's go in here. Now for the terms that are left, the negative 3y squared dy dx and the x dy dx, I'm going to factor a dy dx out. That leaves me with negative 3y squared plus x equals negative y minus 2x. I'll divide both sides by negative 3y squared plus x. And that is our derivative. Just a quick reminder that if every sign were different, okay, and by that I mean let's say you had a positive y plus 2x on top, you had a positive 3y squared and a negative x on the bottom. These two answers are the same, because essentially we're just multiplying the top and bottom by negative 1, and negative 1 divided by negative 1 is 0, so we're multiplying by 1. I'm sorry, negative 1 divided by negative 1 is 1, so we're multiplying by 1. Alright, this other problem, right here we've got the cosine of sine of x, so this is our inside function. We're going to use chain rule. The derivative of the outside, I'm going to write dy dx. Derivative of the outside is negative sine. Leave the inside alone. And then multiply by the derivative of the inside. Derivative of sine would be cosine. So, multiply by cosine. And this is actually our answer. It's tempting when you see this sine of sine to think, oh, is it sine squared? It's not sine squared. This is a composition. We're taking a sine function and plugging it into a sine function. It's not a multiplication of two functions. Now, these rules, you should have a piece of paper, a sheet with these rules on it. These are not rules you have to memorize, but I just wanted to talk about how to apply them. These are the derivatives of the inverse trigonometric functions. Remember, trig functions are for finding sides if we know angles. The inverse functions are for finding angles if we know sides. Okay, so here we've got the inverse secant. So we come down here, the inverse secant. I didn't put cosecant on here. It would be the same basic formula, just be negative. Just like cotangent, inverse cotangent, same basic derivative, it would just be negative. So, inverse secant of u, the derivative is 1 over the absolute value of u, square root of u squared minus 1. So for us, the derivative is going to be 1 over the absolute value of 3x times the square root of 3x squared minus 1, and then we're going to multiply by the derivative of 3x because of chain rule, which would just be 3. So now I'd look and I say, well, I've got 3 over 3x. That could disappear, and I could just be left with 1 over the absolute value of x multiplied by the square root of 3x squared, so 9x squared minus 1. And that's my derivative. Next, we've got the inverse cosine of 4x. Inverse cosine of 4x squared, excuse me. So we go to our inverse cosine derivative. So the derivative would be negative 1 on top, square root of 1 minus 4x squared squared, and then we multiply by the derivative of 4x squared. And by the way, in our formula sheet, that's what this means. It means we're, chain rule, we got to multiply by the derivative of that. So for us, that will be 8x. So our final answer is negative 8x over square root of 1 minus 16x to the 4th. And that's it.